But we have one last kind of instructional lesson. And then over the next couple days, we're going to review some of our past content in just a review game sort of manner, and enjoy each other's company a little bit here. So we'll have a Zoom tomorrow just so I can introduce the setup of the games to you. And then since you're at home, you're welcome to play the games with someone in your home, so it's a little more interactive and fun. Or feel free to just work through the review activities on your own. It's totally up to you, but you'll have an option from, I think I created 10 or 12 different games. You pick 2 for tomorrow and 2 for the next day to play, just to get a taste of some things that we have done this year. And just so you know, there won't be a math packet. I know if you have gone to school here in the past, we've sent home summer math packets, summer reading packets, but they are transferring to more of a digital platform. So we'll continue to use Freckle over the summer. You have complete access to it. You can use the class code that you've been using all year, or you can get into it through using your Star Renaissance login. Has your first name, your last name, remember your birth date. That's how you took the STAR test. You can use that same login information to access Freckle as well. So I'll send an email home to parents just to remind them of that access. But just like it's important to continue reading all summer, get your 20-30 minutes in a day, it's important to hit on Freckle a couple times a week, just so that you don't lose all of this hard conceptual stuff that you've been learning all year. You want to keep it rotating in your brain a little bit so that it doesn't go bye-bye, right? We want to store it in long-term memory. So exposure is the best medicine for that. This object you see in front of you is called a coordinate plane. A coordinate plane is a flat, two-dimensional space, and you can notice there's a grid laying on top of it, right, with some number lines. Those number lines will help us give directions, kind of values, directionality to a certain point on this coordinate plane, or a shape, or maybe if you're looking at it in terms of it being like a map, we'll give 2 values that will indicate its location on the coordinate plane. Has anyone ever seen this shape before, this coordinate plane? Have you ever seen this before?
Yeah, I learned about it in Freckle.
Oh, perfect. And you might have seen simple graphing things maybe in 4th grade or so, that maybe something that is, let's see, I'm going to try and zoom in a little bit more. Come on. Maybe something that was just in this section of the coordinate plane, maybe something that was just in, we'll call that, it's called quadrant 1. Quadrant 1 is where there are positive X values and there are positive Y values as well. Okay, now what do I mean by X and Y values? Well, if you'll notice, there's 2 number lines that are intersecting each other, right? One of those number lines is called the X axis, and the other number line, the one that's going vertically, is called the Y axis. The point at which they intersect, can you see what it's called? What's the point at which they intersect? Where does the X and the Y value? They intersect at the origin. Now, if you think about that word origin, maybe in religion class you've learned about the origins of time, but it means the beginning. And it's kind of like all of the infinicy of the number lines begins at this point. So it reminds me a little bit about its connection to the universe, right? So the origin is the point at which all of infinity begins. So the origin is the spot where these 2 axes meet and everything else goes infinitely out from it in an infinite plane. Now, to locate a spot somewhere on this coordinate plane, I give 2 values. I give a value of where does it exist on the X axis and where does it exist on the Y axis. And that 2 value team is called a coordinate coordinate pair. Now, the word pair means two, right? So a pair of two numbers tell me a location to go on this coordinate plane. So you'll notice that when you see a coordinate value, it's written in this format. The X value is given first, then there's a comma, and then the Y value is given second. And they're both collected into this little bundle by some parentheses. And it connects them together in a package. And this coordinate pair tells you a location somewhere on the coordinate plane. Let's try one. So if I told you the X value is 3 and the Y value is 5, what you would do is you would start at the origin at the beginning, 0, 0, and you would travel 3 units on the x-axis, 1, 2, 3, and then 5 units up on the y-axis, 1, 2, 3, 4, 5. And that spot where the 3 and the 5 meet, that intersection is this location for the point 3, 5. Okay, now sometimes people give the coordinate points, they give them a name. So let's try, if I said point M is at 2, -4, we would again start at the origin. We would travel 2 units in the positive direction on the x-axis, but then go 4 units down to get that negative y value. And we could call it 2, -4, or we could just call it M, because that's a label that goes with that group, goes with that coordinate pair. So there's a couple of different things that we're going to look at in 5th grade, but then some we're going to leave for 6th. For instance, your math book only looks at this quadrant in 5th grade. This is quadrant 1. Quadrant 2 is over here. Quadrant 3 is over here. Quadrant 4 is over here. Now, I know that you can kind of perceive the directions of the other number lines, but we have not studied negative numbers in depth yet. So I think your math book wants to just focus on quadrant 1 right now. Now the other 3 aren't gone. We're just zoomed in on quadrant 1 for today. Does that make sense? So you can zoom in as much as you want to the coordinate plane. So much so that we could even deal with decimal values or fractional values if we're zoomed in far enough into this coordinate plane. So you might see today even our, why didn't the last one go? You might see us zoomed all the way in to like right here. And we'll just be dealing with a tiny, tiny bit of the coordinate plane. And therefore we'll be dealing with some fractional and decimal values as well, okay? How about before we go into fraction and decimal values, we practice a couple more points on the coordinate plane. Does that sound okay? I'll only do quadrant 1 for today, but I just wanted you to see that the other ones exist. Where would I place point B if point B existed at 5, 1? Maybe point right on your screen. Where would 5, 1 exist? So go to the origin, make your X value movement, left to right, make your horizontal movement, land it on 5, boop, and then travel on your Y axis in a positive direction, travel up 1. So this is something that the kids in the other class thought was funny. You imagine going into a building, and then you have to choose which elevator to ride. You choose which elevator to ride based on what is the X value I'm dealing with today. So I'm dealing with the X value 5, which means I stay right on elevator 5. And then I go to the floor where the Y value says to go. So I'm going to floor 1. So I'm going to take the number 5 elevator up to floor number 1, and I'm going to stop right there. Is that where you landed point B? Okay, good. How about point, we'll call it C, at 0, 4. where would 0, 4 be? Well, I start at the origin, and the X value tells me first what left to right movement to make. And this time I make 0 movement. I stay right here, but I take this 0 elevator up to the 4th floor. And so that's the spot that I would land if I were point C. How about point D here? Let's try this one out. 2.5, comma, 3.5. Trying to throw in a little decimal action here. Where would elevator 2.5 going up to floor 3.5, where would that be? Can you put your finger on the screen where you think it would land? I'm at the origin, going over to elevator 2.5, which would be exactly the middle between 2 and 3. That's 2.5. And then take it all the way up past 1, past 2, actually past 3 to 3.5. It would be right in the middle of those values. How'd you do? Good? All right. I think you're ready then. I think you're ready to go on to the workbook page where we'll see on 287. 287. And you'll see a little bit of explanation of the coordinate plane. I liked showing you the entire coordinate plane a little better, so I'll give you kind of a taste of what's to come next year. But we do always give the X value first and the Y value second, no matter what. When we scoot down the page to numbers 1 through 12, we're going to be doing the opposite skill that we practiced right now. Instead of plotting a point, we're going to be looking at a point and giving its 2 coordinate values. So we're going to be writing an ordered pair on the line. Remember, an ordered pair first has this format. It has the X value. Come on, pen. Has the X value in the first position, then a comma, and then the Y value in the second position. And they're bundled together with these parentheses, okay? So let's take a look at point M. Now, point M is here. I can see it meets at 4, but is 4 its X value or its Y value? And if you forgot what the axes are, they have them labeled here for you. See?
It's the Y value, so we have to do the X value first.
So we have to place that 4 in the Y value spot. And we have to go find out what the complementary X value is by going all the way down to the X axis. And what value is there? 1 is on the X axis for M. Do we see that connection there? We have 1 on the X axis and then 4 on the Y axis. Sometimes to check that I have them in the right order, I pretend like I'm plotting the point 1, 4, and if I land in the spot I was supposed to be, then I know I did it right. So I'm at the origin, I travel to 1 first and then go up to 4. There's M, right on the money. So try O with me here. Now, O is way, way, way far out. It's not as high up on the X, on the Y value. But where is the X value that complements O? You're gonna have to kind of draw your eyes down to the X axis. Where is it at? At 5. Oops. Come back. Got it at 5. And what is the Y value that goes with it?
2.5.
2.5. Good job. So Q, we've got 1.5 and 2. For S, we have 3 and 1. What about for you? What are we seeing for you? 2 on the x-axis, right? And all the way up to 5 on the y-axis. W is a little tricky, but follow the routine. What's the x value? It's 2.5. What's the y value for W?
0.5.
Well, 0.5 would be right here, Esther.
Oh, yeah.
So what would the value of W be? Did it go anywhere at all on that y-axis, or did it stay at 0, stay on the axis? Just stayed right on the axis. So if you have a point, you can see letter P is also on an axis, it's on the y-axis, then one of your values is going to be 0. So if the point is sitting on the x-axis, then the y value will be 0. If the point is sitting on the y-axis, then the x value would be 0. Why don't I pause the video for a second and I give you a chance to do N, P, R, T, V, and X right now, okay? And then we'll go through the answers, make sure everyone's comfortable before we move on, okay? So you go and do these even numbered values right now, okay? So for N, we've got, say them with me, everyone, 3,
3.5.
5. Well done. And point P,
0,
0, 3.5.
5.
And for R, we've got 4.5,
5.
4.5.
5.
Yeah. T, we've got 4,
4,
0.5.
5.
V, we've got 0.5,
5.
1.
1.
And X, we've got 4.5,
5.
2.
2.
Good job. It is tricky to see when they're all kind of smushed in there. Some people like to use the edge of a ruler to help them keep focused on what values are there, or the edge of a paper. Check to make sure all your ordered pairs are given a hug with some parentheses. Are they all wrapped up with some bundles? Okay, now we're going to do the opposite skill on this next section and take a look at how do we plot the points now. So I'm going to zoom down here, try to get as close as I can. Now, the thing about this section is they're throwing fractions and decimals at you on the same coordinate plane. So that's going to be something a little bit challenging for us, but nothing we can't overcome. Let me get this out of the way. Everyone can see the entire coordinate plane here, right? So just for sake of giving more detail before you dive into these values, let's look at the coordinate plane and look at what scale has been arranged for us already. Now, if you were making your own coordinate plane, you could choose the scale based on what values you need to plot, but they have designed this little tiny snippet of the coordinate plane only goes from 0 up to 1, right? So we're really zoomed in to this piece of the coordinate plane. So if from here to here is 1 unit, we definitely have decimal values smushed in between here. So if we took the whole and it looks like we split it into 10 parts, then that means that each of those lines, each of those grid lines would represent 1/10. So let's make sure that each is 1/10. I'm going to count from 0 all the way to 1 and make sure that I actually guessed the scale properly. So 1/10, 2/10, 3/10, 4/10, 5/10. So this is good news. Right at 5/10 is the value 5/10. 6/10, 7/10, 8/10, 9/10, 10/10, which is equal to 1, right? So if you want to, this might make your life a little easier. is to go ahead and label a couple of them just to get you going, saying, okay, I know that this line is called 0.4, you know, so that you can later, when you encounter 0.4, you're not so much thinking about where is it located and concentrating more on plotting it accurately. So you can go and label the entire x-axis 0.6, 0.7, 0.8, 0.9, and I'm feeling good. And you could do the same thing on the y-axis, right? The one thing that I'm getting a little suspicious about though is, wait a minute, why are there fractional values when these are all in decimal zone? Are we able to translate between a decimal and a fraction pretty fluently? Sure, we can do that, especially given some of the values I see on the page. So what fraction would go with 0.1? We call it 1/10, right? So how would we write that fraction? 1/10. So 0.1, I'm going to write it in a different color, is also equal to 1/10. How about 2/10? Same thing, 2/10. 3/10, right? Oops, why did I write 2/5? This is Moore's brain is being fuzzy today. Okay, 3/10, 4/10, 5/10. Do we know another name for any of those fractions? Sure. I mean, we could infinitely come up with equivalent fractions. What's kind of the more common name for 5/10? The common name for 5/10? What's another name we could give 5/10? That's pretty common.
1/2.
1/2, yeah. So I might go ahead, guys, instead of writing 5/10, I might just write 1/2 because I know I'm going to encounter that. I can see it here on the page. I see 0.5 right here, but just something kind of to help you along the way as you mark these different coordinate points. So the only thing that we've done so far is kind of take a look at the scale and make sure that our understanding of the values that we're taking a look at on the coordinate plane are in place. Now we can go and plot some values. So point A exists at 0.1, 0.8. So just like always, I first start at the origin, which is right here in the corner where 0 and 0 intersect. And then I travel my pencil all the way to 0.1 or 1/10. And then the y value is all the way up on the 0.8. So I can count 5, 6, 7, 8. 0.8 would be right there. The point goes right at the intersection of those grid lines, but then the label can go anywhere nearby. Can go anywhere nearby. How about point B? The values are, we go to the origin, we go all the way to 1, which is all the way down at the end of this piece of the coordinate plane, and then go up to 1/2. Now, what value matches 1/2 again? Do you remember which decimal value matches 1/2?
0.5.
So we go right there and plot our point. Boop. You have to make that noise. Boop. And label it B. It doesn't work unless you make the noise. I've been told this at teacher school. How about C? 0.4. So traveling to 0.4 on the x-axis. This is the elevator I need, but I'm not going anywhere. I'm staying right here. This elevator is out of service. Sit right on that x-axis. Label me C. Boop. All right. D says use the 0 elevator, which is on the origin, and then go up 1 whole unit. Now, my first reaction was to go right here. But this is only 1/10, right? If I have to go up to 1 whole, I have to go all the way up to this spot right here. Did that part trick you too? Label it D. All right, you try E and F for me. Try E and F. Plot them and then put your hand on your head when you're done so I know that you're ready for us to take a look at them together. E and F. So just those two, E and F. Ready to take a look at those, girls? Okay, cool. So for E, we're at 0.5 on the x-axis and go all the way up to 0.7, boop, and that's E. And for F, we travel to 1/2, which is equivalent to 0.5, but then just up 1/10, which is just one value up here, and label that guy F. So are you feeling a little secure in locating a point and then plotting a point on the coordinate grid? It's kind of fun. Next year, you'll have a couple of occasions where I'll give you the whole coordinate plane and give you a set of points. And if you plot the points in order and kind of connect a line, it makes a mystery picture. So these are really kind of fun things if you feel like Googling up coordinate grid mystery pictures. That's something fun you could do over the summer on a rainy day or something, okay? But it would involve the entire coordinate plane, so you'd have to be a little comfortable moving on the negative side, up and down on the x-axis. But for homework today, we don't need to finish this entire page. You can if you want to, but if you flip to 288, you're going to be doing 1 through 16. Now, I want to look at 1 through 16 first because the scale is different on the grid than the one that we just did. So the one that we just did went by tenths. That was the scale. Tenths, 2 tenths, 3 tenths, 4 tenths, 5 tenths. But the scale on this one is a little different. You can tell we're seeing more of the coordinate plane. So those grids must cover more territory. So let's look at the grid and determine what do each of these tinier grid marks, what values do they represent? So they're equidistant, they're all equally spaced. But if this spot right here is valued at 1, and this one is valued at 2, and so forth, then we can tell that between 0 and 1, there are 4 units. And between 1 and 2, there are 4 units. So basically, we have to split the whole into 4 parts. Now, you could call that 1/4, 2/4, 3/4, 4/4. That would be fractions, 1/4, 2/4, 3/4, 4/4. Or you could call it according to its decimal name. What's the decimal name that matches 1/4? So 1/4 is the same as 1/4 of the way to 100, right? And what value represents 1/4? Do you know? And if you don't know, what do? We divide, right?
Right.
1 divided by 4, we'll set it up. 1 divided by 4. 4 goes into 1, 0 times. And then we say All right, 4 goes into 10 2 times. That would leave 8. We still have dividends, so we're going to bring down one more 0. 4 goes into 20 5 times. And then now I bet you're saying, oh yeah, 0.25 does equal 1/4. Did you remember that now? It matches kind of our understanding of money a little bit, right? That's why it's called a quarter, right? A quarter is worth how much? 25 cents out of a whole dollar. So this is a little connection to our money system. So if the whole is broken into 4 parts, then this little line here could be called 0.25, or we could call it 1/4, right? And this line right here would be called 0.5 or 50, 50 cents. And that matches 2 quarters, which 2 quarters are 1/2 of a dollar. And then this little line here is 0.75, which is how many quarters? 3/4 of a dollar. So 3/4 of a dollar. And then you can just continue the scale past the 1 mark, past the 2 mark. So this would be 0.25, 0.5, 0.75, 1/2, and then keep going. 1.25, 1.5, 1.75, 2, 2.25, 2.5, 2.75, and then we won't have any values that exist on this set beyond 2.75, it looks like. Same thing with the y-axis. 1, 2, 3, 4 units exist between 0 and 1. So we split them into 4 parts. 1/4, 2 quarters, 3 quarters, 4. Okay, so I just wanted to take a minute to show you that the scale had changed for exercises 1 through 16 here. And sometimes it looks like you're given a value as a fraction, and then sometimes as a decimal as well. So you can kind of pivot between those 2 formats. This is a nice review of what we've studied in fraction and decimal land this year. Okay, so stop at 16. That'll do it for today. We'll have one more Zoom tomorrow and review a little bit of this and then introduce our game. Okay, Michael, what's your question?
So on some of the numbers in the second section, there are mixed numbers.
Sure. So notice that the scale goes past 1. So you can have a point. I'm even looking over here at K, for instance. K's X value is past 1. So I could call that 1 1/4. So I would call that 1 1/4, or I could call it 1.25. Either way, that would be the X value that goes with K. What would the Y value that goes with it be? It'd be under 1, 1/4, 2/4, 3/4. So I could call it by its fraction name, or I could call it by its decimal name. And either way, you would be right. If it makes you more comfortable to convert it to an improper fraction, you can do that. You just know that anything over 4/4 represents a quantity bigger than 1. So 5/4 or 6/4 or 7/4, it just keeps on going down that number line. It's just a different name for it. It's the same value, it's just a different name for it.
Okay, thank you.
Any more questions, guys? What are you thinking? Feeling okay to give this a whirl? Okay. Just quadrant 1, just zooming into quadrant 1 today. And then we'll expand your horizons next year a little bit, okay? Have a great rest of your day.
You too. Bye.